morning. I am Sumithra, Associate Professor, Department of Physics, working at Manakula Vinayagar Institute of Technology, Puducherry. Now, we are going to see about an advanced engineering material known as shape memory alloys. It is also known as smart material, as well as it is also known as memory alloys. We would have known about alloys. Alloys normally means combination of two or more metals. Why do we make alloys? Alloys are being prepared to enhance its property and to gain more industrial applications. Here, this specifically material alloy that we are going to see is known as shape memory alloy. Why it has got its name like that? For example, if you are taking a normal alloy, when we heat it, they change their shape. When they are being again cooled, they won't be gaining any original state, but instead they appear to come in a new form. But whereas when you are taking a shape memory alloy and when you are subjecting it to thermal procedures, what happens? They regain their original shape or they recover their original shape. So this peculiar property we can see in your smart materials or otherwise known as shape memory alloys. Shape memory alloys in short form, they are known as SMEs. So shape memory alloys when we take, they have got wide range of applications. We will sector it into two. One is named as industrial application, the other one is named as medical applications. When we consider the industrial applications, many advanced applications we can see in there. First thing that we can see is your cryofit, hydraulic, tube coupling, and secondly we can see them used as temperature control system. They are being used as force actuators. So when we take this cryofit hydraulic tube couplings, for joining two tubes together, it is highly difficult. Either we have to apply the welding process or some other process. As your shape memory alloy has got an unique property, due to the change in their temperature, they can change their shapes. So to join two tubes, what you can do is you can make use of a shape memory alloy, insert between the two tubes, and then due to their temperature variation, what they do, they get fixed between the two tubes and get connected. Then second, when we call it as temperature control system, due to this temperature control system when we take, they will be used in switches or they can be used as variable resistors for controlling any system devices. Next, when we see force actuators, they are being used to shut off flammable toxic gases due to their temperature variation. So this type of applications we can see on the industrial side, and we take medical applications. They are being used as blood clot filters. Then they are used as eye frame glasses. In tumor identification. They are used as catheters, etc. So mainly you can see that the temperature variation changes the shape of the smart materials. That's why they are being used in blood clot filters. They are being used in eye frame glasses. They are used in tumor identification, catheters, and as it has got the biocompatibility property, they are used in bone plates, and also they are used in preparing the hip joints materials, hip joint materials. So wide range of applications our shape memory alloys have got. So next we have to see how they are being classified. There are two types of shape memory alloys. One named as one-way shape memory alloy and the other one named as two-way shape memory alloy. So next let us see about its type. So one type is named as one-way. In short, we are writing it as SMA, shape memory alloy. And secondly, we have got another type named as two-way shape memory alloy. So when we are taking one-way shape memory alloy, they will be exhibiting the characteristics, that is regaining its shape only on heating alone. But when we take two-way shape memory alloys, they will be regaining their shape both on heating and cooling process. So these are the two types of shape memory alloys that are available. One is on heating process, the other one will be gaining its process both on heating and cooling process. So next we have to say the different phases that are undergone in our shape memory alloy. So when we take the phases, there are two types of phases. So they undergo two phases. One phase is named as Martensite phase. The other one named as austenite phase. Two phases occurs in shape memory alloys. One is Martensite phase, the other one is named as austenite phase. Martensite phase will occur at very low temperatures. When the material is taken at very low temperatures, they will undergo a phase named as Martensite, where you can see the material will be very soft and deformable. But that same material, when it is undergoing the austenite phase, that is when you are increasing the temperature, which means that it happens only at very high temperatures, there you can see that the material goes into a stronger one. In Martensite, the material will be soft, but whereas in austenite, the material will be very harder. So both are, what you can do is you can change their states by heating and cooling process. That is the extraordinary unique property your shape memory alloys have got. So then next we will see an important part of a shape memory alloy, which we have to look into, their characteristics or properties. Shape memory alloys have got three important properties. Let us see. One property if we take, it is known as shape memory effect, which is very important property. To know about the shape memory alloy, we have to certainly know about shape memory effect. What is shape memory effect? You are taking a shape memory alloy. For example, you are taking your retinol and you are going to subject it to some temperature. For example, initially the material will be at low temperature, normal room temperature. When the shape memory alloy is in normal room temperature, it will be in what state? It will be in Martensite state. So next what you are going to do is, this type of Martensite state is known as twinned Martensite state at normal room temperatures. But when you are going to apply with some load, it changes into another form of Martensite state, which is known as deformed Martensite state. So again, this deformed Martensite state, when it is being heated, you know that your Martensite will be getting converted into austenite. So when the material is being heated, it reaches the stage named as austenite stage. Again, when you are cooling the austenite, what happens? Your material will be regained into your Martensite state. So you can see in this graphical representation, by changing its temperature, what happens to your shape memory alloy. So this type of effect is known as shape memory effect. So next property that we are going to see is known as pseudo-elasticity. It is named as pseudo-elasticity. Pseudo means false. All of you know. Elasticity means a material which will be regaining its shape when you are applying the load, or also if you are removing the load. So what is that pseudo-elasticity in your shape memory alloys? If you are taking a shape memory alloy, what you have to do? Initially you have to heat it. When you are heating your shape memory alloy, it changes or it will be getting transformed into a stage named as austenite stage. So next what you have to do, you are not either going to decrease the temperature or you are not going to increase this temperature. It is going to be in austenite phase. But you are going to apply some load over the austenite material. When you are applying the load, what happens? You are not changing the temperature. Your temperature will be constant here. Your temperature is constant and you are applying with an austenite stage. When the load is applied, your material gets changed into Martensite state. You know this well. Again, on removing the load, what happens? When your load is being removed, your material will be again getting changed into your austenite. We are not at all changing the temperature. Normally what happens when you are taking your shape memory alloys, when you are heating it or cooling it, these two transformations will be happening. But without the temperature variation, what happens? Just by applying the load alone, temperature is fixed, by applying the load, you are able to get this Martensite and austenite stage of your shape memory alloy. So this property is known as your pseudo-elasticity property. And the last property that we are going to see is the hysteresis. When you are taking the hysteresis, what happens? Third property is known as your hysteresis, and if you are seeing the hysteresis property, what happens? The transformation or the temperature changes, even though they are happening in wide range, there is no overlapping of transformation happening over here. So when you are putting it as a graph, you get a balanced graph similar to that of your hysteresis curve. So by seeing this, your shape memory alloy, you are able to see it has got wide range of applications both in industries and medical applications due to its temperature variation factor. Thank you.